so we're starting Unit 7 today. Unit 7, the next couple of units that we're going to do all have to do with geometry, and so Unit 7 is kind of an introduction to geometry, so we're going to do a lot of how to name points, how to name lines, how to name planes, that kind of thing, and then just kind of working with identifying different pieces of it, and then we'll start doing a little bit of problem solving using geometry, and then that'll build the foundation for the next couple of units where we get a little bit more in depth into geometry. So some of this stuff might be review for you, okay? So just bear with me, make sure you write it down because I want to make sure that we all have the same terminology and that we are all labeling everything the same so it's consistent, okay? So the first vocabulary word is a point. A point indicates a location and it has no size. So it doesn't matter if you draw it really, really big or a teeny little dot, it's still a point. We always name points with a capital letter. So usually we start X, Y, Z or A, B, C, but really you can name points anything you want, but they always should be named with a capital letter, okay? The next thing that we need to look at are what points make up. Points make up a line. And a line is represented by a straight path that extends in two opposite directions without end. So that means that lines go how long?
Forever.
Forever and ever. And we indicate that because at the edges of the line we put arrows, which means it goes on forever and ever, okay? And lines also have no thickness. So it can be a really thick line, it can be a really thin line, they're all the same. The other thing about lines that you need to know is that they contain infinitely many points. So even though on a line you might only see 2 points labeled, there's actually an infinite number of points that lie on that line. Does that make sense? Because it goes on forever and ever. We have two ways of naming lines. We can name a line by 2 points that lie on the line. So, and we put the little line symbol right above those 2 points. So we can call this line that I drew line AB. Or we can also give lines a specific letter that represents the entire line. Usually that happens when there aren't 2 points identified. And so this one is called line L. Lines are named by using a lowercase cursive letter, okay? So lowercase cursive letter. So we would call that either AB or L. They mean the exact same thing. It's usually preference or whatever information is given to you. Points and lines lie in what is called a plane. A plane is represented by a flat surface that extends without end and has no thickness. So it's just a flat surface that has no thickness and it goes on forever and ever as well. It contains infinitely many lines. So you can draw an infinite amount of lines in a plane. Usually when we represent a plane in geometry, we represent it by a parallelogram, which is kind of like a slanted rectangle. And we can name a plane using 3 points inside the plane. So this plane that I drew contains points A, B, and C. So we can identify it by calling it plane ABC. You must use 3 points. Or we also identify it with a capital letter, just like we do a point. And we could call this one plane P. So usually if a plane is represented by a capital letter, that letter is in one of the corners and doesn't have a point next to it. So that's how you know that that's the name of the plane. So when points lie in the same line, we call those collinear points. So if we ever have more than 2 points that fall on the same line that are identified, we have a special name for those. Those are called collinear. So I drew a line and it contains points A, B, and C. So we would say that points A, B, and C are collinear. Okay, so when we have multiple things that lie in the same plane, those are called coplanar. And coplanar items can refer to points and lines. Okay, so points and lines that lie in the same plane are called coplanar. So here's my little plane, and I put 2 points A and B and line L in there. So we would say that A, B, and line L are all coplanar. Okay, so when we cut off a line between 2 endpoints, we call that a segment. So a line segment is part of a line that consists of 2 endpoints and all points in between them. So I drew a segment. So a segment does not have arrows at the end because it does not extend forever. You actually can find the length of a segment. Okay? So since we have two endpoints here, it's considered a segment. So when we write out a segment, we just put a straight line through it with no arrows on the end, and then the endpoints go underneath. So this would read as segment AB. Okay, so we also have what's called a ray. Now, I want you guys to be careful on this one. I split this box into two because I have two little things. If you want to use separate boxes, that's okay as well. I think we won't run out of space in the end, so you can do two separate boxes if you want. Okay, so a ray is part of a line that consists of only one endpoint and then all of the points on that side of the endpoint. So, for example, if I took line AB and then I just cut off one side, I only have one endpoint and the rest of the line extends forever and ever. But I notate that as ray AB, and I just put the line going in one direction. Now, even if your ray extends to the left direction, you still use this same notation. Does that make sense? So it doesn't matter which direction your ray is going, you will always use an arrow pointing to the right to notate that it's a ray, okay? So don't start pointing arrows all in opposite directions. And then the reason why I put these in the same box, although for mine it didn't quite fit, is that they're related. We also have what's called opposite rays. And opposite rays are rays that share the same endpoint and they form a line, but they go in opposite directions. So for example, I have this line that contains points C, A, and B. Ray AC and ray AB are considered opposite rays because they go in the opposite direction. In math, we have what are called postulates, or sometimes they're called axioms. They're essentially the same thing. We're going to use the term postulate, but you might sometimes see the term axiom. They mean the same thing. Okay? A postulate or an axiom is an accepted statement of fact in math. Okay? So, for example, okay, so mine is page 66, yours might be 68, but we're doing 7.2, points, lines, and planes. Points, lines, and planes. Okay, so postulate 1. So here's what I did. I wrote it really big because you are going to need to know these. And then I wrote the definition right next to it, and then I did an example right underneath. Okay? So postulate 1 says that through any 2 points, there's exactly one line. You probably already knew this, right? That if you have 2 points, you can draw a line through them. But now we're giving it an official name. So postulate 1 says that through any 2 points, there is exactly and only one line. So I put 2 points A and B, and then I drew a line through them, and I called that line T. So then I just did a little written out explanation of what's going on here. Line T passes through points A and B. This does say line. Line T is the only line that passes through both points. There is no other line that you can draw that would go through points A and B. That is not line T. Postulate 2 says, if 2 distinct lines, meaning 2 different lines, intersect, then they intersect at exactly 1 point. That also should just be logical reasoning, right? If 2 lines intersect, they can't intersect more than once. So I drew line A, C, and B, or AB, just kidding, and then I drew line DE, and I said their intersection point was point C. So line AB and line DE intersect in point C. Postulate 3 says, and this one is the one that took up the most space on mine, if 2 distinct planes intersect, then they intersect in exactly one line. So basically, if we take 2 planes and we intersect them, a line forms through the intersection. Okay? So this is very difficult to draw, so just do the best you can. I drew this plane that contains points R, S, and T, and then right through it, I drew a plane that contains points S, T, and W. And the The dotted lines mean that that's where they're overlapping. So it's like if it was clear, you could see through it. And then straight through them, where they intersect, they form a line through ST. So we would say plane RST and plane WST intersect at line ST. Okay, so postulate 4 says that through any 3 non-collinear points, so if I have 3 points, but they do not all lie on the same line, then we can draw exactly and only one plane through those points. So basically, 2 points make a line, 3 points make a plane. Okay? So here's a plane. I called it plane P, and I put the points R, S, and Q in there. So we would say that points R, Q, and S are non-collinear because they don't all form one line. Plane P is the only plane that contains all 3 of those points.
Back already? It's over?